Pythagorean theorem. The Pythagorean theorem states that in a right triangle, the square of one leg plus the square of another leg is equal to the square of the hypotenuse. We know this is a squared plus b squared equals c squared, where a and b form the 90-degree angle and c is the hypotenuse, the longest side of the right triangle. So here we have two right triangles, and we need to solve for the missing leg. So we're going to use the Pythagorean theorem. We're going to take a squared plus b squared and have it equal to c squared. So 6 squared plus 8 squared equals x squared. X equals 10. Here we have another problem. In this instance, we're going to solve for the leg. So we have 12 squared plus y squared is equal to the hypotenuse, or 13 squared. And when we solve, we find that y is equal to 5. But there's an easier way to do this using our calculator. So let's think about this. We have a side length of 6 and a side length of 8. We're trying to find a bigger side, the hypotenuse. So in this instance, we can use what we know as the Pythagorean theorem. 6 squared plus 8 squared, and then hit enter. Now you know the square root of 100 is 10, but let's say it's a big number, and how could we use the calculator to input that for us? So let's hit second, and then the square root button, so x squared, and now you could type in 100, or you could hit second, and go down to the negative sign, and you see in blue it says ANS, so answer. So if I hit that, it's going to give me the square root of the answer, which is 10. So that's one way to do that on the calculator. And then other example we had, we were trying to find the leg, or the smaller side. So we are going to, instead of doing a squared plus b squared equals c squared, we're going to take c squared minus a squared and get b squared. It'll save us some steps. So again, we can use our calculator. We're going to take the biggest side, which is the hypotenuse. We know that, 13 squared, minus a leg of 12 squared. Enter. And that gives us 25. So I'm going to go ahead and pretend like I don't know the square root of 25. I'm going to hit second square root, second negative, enter. So that side length is 5. So that can save us some times when we're solving these problems. Another way to save time, we could memorize or become familiar with the Pythagorean triples. The Pythagorean triple is a right triangles whose side lengths are a set of integers. So that means their side length would be 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, and 25. These are all Pythagorean triples. So a squared plus b squared equals c squared, and they're all integers. But there's more than that, and you can take any one of these, and a multiple of that would be a Pythagorean triple. So, for instance, a 3, 4, 5 triangle, if we multiplied each side by 2, we'd get a 6, 8, 10. If we multiplied by 3, we'd get a 9, 12, 15. All of these are right triangles that are considered Pythagorean triples. So these are our Pythagorean triples and any multiple of them. So if we go back and think about that first example, when we had a 6, 8 side length, we could, if we are familiar with our Pythagorean triples and saw that that was the 3, 4, 5 doubled, we would have to do absolutely no math, and we could find that that was 10. And in our other example, we had a 12 and a 13. If we know our Pythagorean triples, again, we don't have to do any math. We would know that's a 5, 12, 13.